All right, well, welcome back. We're going to do some more trigonometry, and this is what students I find love. And when I say that, I mean I'm very sarcastic. But no, really, what we want to do is we want to simplify trigonometric expressions. And what we're going to use is the fundamental trig identities. Oh yes, the fundamental trig identities. All right, now there are many fundamental trig identities, and what I would suggest doing is if you haven't gone and found some of the fundamental trig identities and copy these down or look in your book or whatever, I would do that. All right. I'm going to make reference to them throughout these videos, but if you're wondering, where is he getting these things from? Just type in fundamental trig identities, all right, co-function identities or whatnot, and you will be able to find these answers. So without further ado, let's see if we can figure this out. So we want to simplify these fundamental trig identities. So now in order to do this, what we have is we have cosine squared of pi over 2 minus x. All right, now when you have this one right here, now there's one fundamental trig identity that we want to do here, is that we notice that we have a co-function identity. This is a co-function identity. It's an O, by the way. All right, identity. Identity, there we go. Identity. Now, for the full co-function identity, we know that cosine squared pi over 2 minus x, this is going to equal sine. And since it's just squared, all right, and just so you know, all right, cosine, all right, of the quantity pi over 2 minus x, all right, that is going to equal, all right, sine of x. All right, that equals sine of x. So, because this is just simply squared, we know that this quantity, when it's squared, is going to equal sine squared as well. All right, so we're going to just put that in there. So we're going to actually substitute and use the substitution and sub in sine of x squared, all right, for that one. So we can simplify this. So we have sine of x squared over cosine of x. All right, so now from here, what we can do is we can simplify this, and because now we have sine squared, we can write it as sine of x over cosine of x and times sine of x. And so what we get here is going to be tangent of x times sine of x. Now there are more than one ways of doing this, and different people have different things of how they would simplify it, but that's where I would probably simplify it to tangent of x times sine of x. Even though technically this would also be simplified if you think about it. So that would be my answer I would find. Okay, so we're using a fundamental trig identities and co-function identities to help us out. All right, now here's another one. All right, we have secant, all right, to the fourth of x minus tangent to the fourth of x. Now, we're going to use algebra here. Now, if you don't know, this right here means we have secant of x to the fourth minus tangent of x to the fourth. That's what that little 4 means, okay? Now, from here, we used to have like values. If I would have, like, for example, just, let's make it y to the fourth minus z to the fourth, we could actually write this as y squared minus z squared times, all right, y squared plus z squared. Correct? No, hopefully it's correct. That's what we can do, all right? This is a, all right, difference of 2 squares. And right here, this is what we're going to be looking probably to do here as well. We're going to use the difference of 2 squares to separate this through. So I'm going to use the difference of squares. So we're going to use algebra to help us figure this out. So a lot of algebra is being done here. Now, when we do this, what we have is this is going to turn into secant squared, all right, of x. All right, let's put the square down there, minus tangent squared of x. And this is going to be multiplied by secant squared of x plus tangent squared of x. Let me have that. Now from here, we have to use one of our fundamental trig identities, and that's what we can do right now. So in this one, we have secant and tangent, and what we know is that all fundamental trig identities come from this sine squared of x plus cosine squared of x, that equals 1. Now, right here, if we want to get tangent and secant, if I divide by cosine, all right, another trig identity is going to be, all right, tangent squared of x plus 1 equals secant squared of x. So what I can do for every single one of these is wherever I have a secant squared, I can input tangent squared plus 1. And that's what I'm going to do. So I'm going to take this right here. I'm going to put in tangent squared of x. And that's the secret. All right, plus 1 minus tangent squared of x. Right here, what I'm going to have right here is I'm going to go tangent squared of x. All right, plus 1. And I have plus tangent squared of x. From here, what do you notice? The tangents will cancel out, correct? And this 1 is going to be 1, so we have 1 times, I'm going to simplify this, tangent plus tangent is going to be 2 tangent squareds of x. And that's going to be plus 1. All right? And that's what we got right there. All right? Yeah. Okay. And I don't know if they can go any farther, but I would probably say that is where I probably would maybe say simplify. Tangent, I could maybe say secant minus 1. So maybe, well, we still have a secant. We have minus 1. I don't know if there's any farther we can go. I'd probably say that's where I would stop. All right, use the fundamental trig identities, simplify this into a different expression. All right, and that would be our simplified answer. All right. Well, hopefully this helps you out. I'm going to have some other tutorials on how to simplify trigonometric functions or expressions later on. So this is the first of several that I'm going to be posting on YouTube. Good luck and God bless in the rest of your trig problems.